In this video, we're going to discuss about divergent sequences. So let's have the definition. A sequence is divergent if it is not convergent. So napakasimple ng definition ng divergent. Kapag ang sequence hindi convergent, automatic divergent. So isa lang ang ibig sabihin niyan, dalawa lang ang patutunguhan ng ating sequence. Pwedeng convergent, pwedeng divergent. So let's have example. Okay, so let's have our example. Show that the sequence -1 quantity raised to n from 1 to infinity is divergent. So ano ba yung itsura ng sequence na yan? So ganito yung itsura niya. -1 raised to n equals 1 to infinity. This is equal to, simulan natin sa 1, -1 quantity raised to 1, that is -1. Tapos raised to 2, that is 1. Then -1, 1, and so on. Okay? So as you can see, sa odd numbers, puro -1. Tapos sa even terms naman ay puro +1. So ipoprove natin na divergent siya. So let's have our proof. Okay. Now, so hindi natin magagamit yung theorem ng convergent sequence about bounded kasi itong sequence na to ay bounded. Hindi kasi siya lumalagpas ng -1 tsaka 1. Okay? Now, ibig sabihin, yung theorem natin sa convergent sequence na lahat daw ng convergent sequence ay bounded, hindi natin pwedeng gamitin yon. Okay? Kasi yung theorem na yon, pwede natin siyang gamitin. Halimbawa, ang isang sequence ay unbounded. So, ibig sabihin, pwede nating masabi na hindi siya convergent. Divergent siya. Okay? Kasi, sabi nga sa theorem natin, lahat ng convergent ay bounded. Okay? Ibig sabihin, kapag hindi bounded, hindi siya convergent. Okay? Now, kung bounded to, tapos napatunayan natin na itong bounded sequence na to ay divergent, ibig sabihin, hindi lahat ng bounded sequence ay convergent. Okay? Now, i-prove na natin to. So, i-assume muna natin na convergent to. So, suppose sequence -1 raised to n equals 1 to infinity is convergent. Okay, so okay lang yon, i-assume natin na convergent siya, total bounded din naman siya. Okay? Now, ang goal natin, makapagpalabas tayo ng contradiction or makapagpalabas tayo ng false statement para masabi natin na mali yung ating hypothesis at doon mako-conclude natin na dapat yung sequence ay divergent. Okay? So, now, let's proceed dito. So, kung ang hypothesis natin, yung sequence na to ay convergent, by definition of convergent sequence, meron siyang limit. Okay? So, let limit ng -1 raised to n as n approaches infinity is equal to L. At ilet na rin natin yung epsilon to be equal to 1. Okay? So, pwede to. Okay? Kasi mas madali siyang tignan or mas madali siyang maintindihan kapag magse-set tayo ng epsilon, value ng epsilon specifically equal sa 1. Ang goal lang naman kasi natin, dapat makapagpalabas tayo ng false statement. Kasi kung convergent talaga yung sequence na to, dapat for any epsilon, okay, satisfy yung definition ng convergent sequence. For any epsilon. Pero since ang goal natin, magpalabas tayo ng false statement, mag-set tayo ng isang epsilon, okay lang yon. Okay? Now, by convergent sequence, may mag-e-exist na natural number n such that for all n greater than or equal to n, the absolute value ng -1 raised to n minus L is less than 1. Ito yun. Okay? Now, but if n is odd, so katulad ng pinakita ko kanina sa sequence, puro -1 na lang yung odd, no? So, ibig sabihin, if n is odd, then the absolute value of -1 na lang siya, minus L is less than 1. And this implies Ilabas natin yung negative. So, absolute value ng negative 1 plus L less than 1. And this is also implies, pwede nang tanggalin yung negative kasi naka-absolute value naman siya. So, absolute value ng 1 plus L less than 1. So, absolute value ng negative ay equal lang yan sa absolute value ng 1 plus L. Okay? And by property of absolute value, this is negative 1 less than 1 plus L less than 1. And mag-subtract tayo ng 1 sa lahat ng sides na yan. This implies negative 2 less than L less than 0. Okay? Sa kabilang banda, if n is even, then yung 1 minus L, kasi sa even, puro 1 naman yung lumalabas, less than 1. This implies, by property of absolute value, okay lang yan, na yung 1 minus L, gawin nating L minus 1. So, they are equal. Less than 1. And this implies negative 1 by property of absolute value again, less than L minus 1 less than 1. And mag-add tayo ng 1 sa lahat ng sides na yan. This implies ito ay magiging 0 less than L less than 2. Okay? So this is inequality 1 and this is inequality 2. And as you can see, yung L natin magulo. Ano ba talaga siya? Yung L ba talaga ay greater than negative 2 less than 0 o greater than 0 less than 2? So hindi niya masatisfy yung dalawang inequalities na yan. Dito sa definition ng convergent sequence na for any n greater than or equal to n, yung distance nito ay less than 1. Pero hindi natin alam kung ano yung L na to kasi yung L na to magulo, hindi niya masatisfy yung dalawang inequalities na to. Okay? So since L cannot satisfy both inequalities 1 and 2, ito, then the hypothesis that yung sequence natin negative 1 raised to n equals 1 infinity is convergent leads to contradiction. Okay? So therefore, kung nakakapag-produce ng contradiction yung ating hypothesis ng sequence na to ay convergent, so mapo-force tayo na tanggapin na yung sequence na to ay divergent by definition of divergent sequence. Kasi kung hindi siya convergent, that is divergent. So therefore, the sequence negative 1 raised to n from 1 to infinity is divergent. And this is done. Okay, so let's have another definition. Let a sub n be a sequence. Definition number 1. If for any positive number m, there exists a natural number n such that for all n greater than or equal to n, large N, the sequence a sub n is greater than m. Then we say that the sequence is diverges to positive infinity. And we write limit of a sub n as n approaches infinity is equal to positive infinity. And for number 2, if for any negative number m, there exists a natural number n such that for all n greater than or equal to n, a sub n becomes less than m, then we say that the sequence a sub n diverges to negative infinity, and we write limit of a sub n as n approaches infinity is equal to negative infinity. Okay, so anong sinasabi ng dalawang definition na yan? So yung definition 1, pinapakita niyan or dinedefine niya yung sequences na nagda-diverge sa positive infinity. Okay, so masasabi daw natin na nagda-diverge ang ating sequence sa positive infinity kapag sa lahat ng positive real number o sa kahit anong positive real number m, palagi tayong nakakapag-provide ng natural number n such that as n becomes larger than this natural number, yung sequence natin ay naging mas malaki na doon sa positive number na yon. Okay? Ibig sabihin, yung sequence nagda-diverge sa positive infinity. Dito naman sa number 2, dinedefine naman niya yung sequences na nagda-diverge sa negative infinity, which is for any negative number m, kapag palagi tayo nakapagpo-provide ng natural number n such that as n becomes larger than this natural number, yung sequence natin becomes smaller than m. Yung negative number m na yun. So, ibig sabihin nun, yung sequence nagda-diverge sa negative infinity. And for number 3 naman, the sequence is properly divergent if either yung limit niya is equal to positive infinity or yung limit niya is equal sa negative infinity. In short, ang dinedefine natin dito ay yung properly divergent sequences. Okay? So, let's have our example para maintindihan natin. Okay, so let's have number 1. Show that limit of the quantity square root of n plus 7 as n approaches infinity is equal to positive infinity. So dito, i-apply natin yung definition, yung unang define natin, yung sequences na nagda-diverge sa positive infinity. Okay, so let's have discussion first. So for our discussion, dapat ang goal natin dito, makahanap tayo, find natural number n such that for all n greater than or equal to that natural number, dapat yung absolute value, yung square root ng n plus 7, yung sequence ay naging greater than m na as n becomes larger that natural number. Okay? So yan yung una nating goal for our discussion. Hanapin natin, dapat makahanap tayo ng natural number n. So paano tayo hahanap? Gagamitin natin ito. So consider square root of n plus 7 greater than m. This implies, ilipat ko yung positive 7 sa kabila, magiging square root of n greater than m minus 7. Or parang nag-subtract lang ako both sides ng negative, ng 7. Okay? Then, i-square natin to both sides. So, this implies n greater than m minus 7 squared. Okay? Now, pwede na nating sabihin na by Archimedean property, since ito ay a real number, and according to Archimedean property, palagi daw may natural number na mas mataas sa kanya. So, let's say, yung natural number na yon ay yung n. O, yun yung nahanap natin na large n. So, i-choose n to be greater than quantity m minus 7 squared. Okay? So, proceed tayo sa formal proof. Okay, so para sa ating proof, so let m be greater than 0 and choose n to be greater than m minus 7 quantity squared. So dapat mapatunayan natin dito, given sa assumption na to, na for all n greater than or equal to n, dapat yung square root of n plus 7 kanina mas malaki na dito. Okay, yun yung goal natin. Okay? Now, so, for all n greater than or equal to large n, since yung large n natin ay greater than dito, so ibig sabihin, yung n natin ay greater than dito. M minus 7 squared. Reverse process lang ulit tulad nung nakaraan sa convergent sequence. So, ganun din dito, no? Nag-reverse lang tayo, square root natin both sides. So, this implies square root of n greater than m minus 7. And dito naman, ilipat natin yung negative 7 sa kabila. So, this implies square root of n plus 7 is greater than m. And as you can see, for all n greater than or equal to n, napatunayan natin na yung square root of n plus 7 is greater than m. For m greater than 0. And by definition of divergent sequence na nagda-diverge sa positive infinity, so therefore, yung limit ng square root of n plus 7 as n approaches infinity is equal to positive infinity. And this is done. Okay, so let's have another example. Show that limit of negative n over 2 as n approaches infinity is equal to negative infinity. So ito naman, gagamitin naman natin yung second definition kanina, okay, about divergent sequence na nagda-diverge naman sa negative infinity. Okay, so for our discussion muna, so hahanap muna tayo ng natural number n. So find natural number n such that for all n greater than or equal to n, dapat yung negative n over 2 ay less than m, for m less than 0. Okay? So para makahanap tayo ng natural number n, so gamitin natin to. So consider negative n over 2 less than m. So this implies negative n less than 2m. So nagmultiply lang ako ng 2 sa both sides ng ating inequality. Okay? Tapos magmumultiply ako ng negative 1 sa both sides niyan. So this implies positive n, kasi negative times negative, that will be positive n. Tapos ang ating inequality magiging greater than na. Okay? Kasi nagmultiply ako ng negative eh. So mababago yung symbol and this is greater than negative 2m. And since ito ay real number, so by Archimedean property, palaging may natural number na mas mataas dyan. So let's say yung natural number na yon ay yung n na yon, large n. Okay? So choose large n to be greater than negative 2m. Okay? So proceed tayo doon sa ating formal proof. So para sa ating formal proof, so let m less than 0. So ginagamit natin yung second definition ng divergent sequence, ha. And choose large n to be greater than negative 2m. Then for all n greater than or equal to n, reverse process lang, n is greater than negative 2m. Since yung n ay greater than or equal dito at yung large n ay greater than negative 2m, so ibig sabihin yung small n ay greater than negative 2m. And this implies mag-multiply tayo ng negative 1/2 both sides. So multiply tayo, magiging negative n over 2, and since nagmultiply tayo ng negative, mababago yung symbol from greater than magiging less than, tapos dito ang matitira na lang ay m. And napalabas na kagad natin, for all n greater than or equal to n, negative n over 2 is less than m. So by definition ng divergent sequence na nagda-diverge doon sa negative infinity, yung limit ng negative n over 2 as n approaches infinity is equal to negative infinity. And this is done. Okay? So, ganun lang kasimple. Mas madali siyang i-prove yung divergent sequences kaysa sa convergent sequences. Okay? So, ibig sabihin, by the way meron tayong tinatawag na properly divergent kanina sa ating definition. Kapag nagda-diverge sa positive infinity o nagda-diverge sa negative infinity, ibig sabihin properly divergent yon. Pero hindi lahat ng divergent sequence ay properly divergent, kasi yung una nating example kanina, hindi siya nagda-diverge sa positive infinity, hindi rin siya nagda-diverge sa negative infinity. And actually, yung binigay nating sequence na prove nating divergent ay bounded. Okay? So hanggang dito lang para sa divergent sequences.